So one of the fundamental theorems of calculus says that if you're taking a derivative from some a to some x of capital F of x, which means the antiderivative of a function x, then the antiderivative is going to be lowercase. Sorry, this should be t dt, different variable. If you try to take a derivative of this function, then you're going to be back to the original function f of x. The integral asks us to evaluate the antiderivative. So we're doing the same thing in this question, except we're going to have to remember the chain rule when we take a derivative. So the derivative of the antiderivative is going to be itself, but then we need to evaluate the limits of integration, and we're taking a derivative, so we have to also multiply by the derivative of these innermost functions. So if you plug in the first limit of integration, you get 6x squared, but we were taking a derivative originally, so the derivative of the innermost function is 2x. Then we subtract what happens when the function, so it's tangent, and then we're plugging in the square root of x. Oh, and there's a 6 there. But then we also need to multiply by the derivative of the innermost function. So the 1/2 comes down, and then the 1/2 power gets reduced by 1. So if you clean that up a little bit algebraically, the 2x usually goes out front of a trig function. That's not required. And then over here, this is a negative power, so we can make that positive by putting it in the denominator. So that's all over 2 square roots of x. So there's our derivative.